Hello everyone, welcome to my vlog, and in this video, we are going to talk about multiplicity of roots and the behavior of the graph. So what do we mean by multiplicity and how does it affect the behavior of the graph of a polynomial function? If you try to recall in our previous video, we have talked about sketching the graph of a polynomial function, whether the left hand is falling or rising, or the right hand is rising or falling, no? So in this video, we are going to focus on multiplicity, but let us not forget the rising and falling of the left hand. When can we say that it's rising and when can we say that it is falling? So you have to recall that, and if you have not watched, you can look at the link in the description box. And also, if you are new in this channel, kindly hit the subscribe button and the notification bell so that you will get notified whenever there is new upload. So going back, let us now do this activity so we would know the effect of multiplicity of roots to the graph of a polynomial function. But before that, let us first define what multiplicity means. So according to the book here, we have the definition. Multiplicity of roots tells us how many times a particular number is a root or zero of a given polynomial. So when we say root or zero, it means that our y will equals to 0. Okay? So in other terms, this is actually called our x-intercept, because these numbers are found in the x-axis because y is equals to 0. So it is here in the x-axis. For example, looking at the graph, our zeros here are this one, -2, -1, +1, because these points of the graph crosses the x or touches the x-axis. So that's why it is called root or 0. So how are we going to determine the root or 0? So to determine, let us go back to the given polynomial function. So it is easier to determine the 0 or the root of a polynomial function if it is already in factored form. So as you can see, how many factors are there? There are 1, 2, 3, 4. So there are 4 factors. And as you can see, there are exponents, no, in some of the factors of the given polynomial. So we would know later as we go on in our discussion what is the purpose or what does the exponent there reflect or tells us. Okay, so first let's get the roots, because this is the first column of our table. So in getting the roots, let's get the factors of the given polynomial. So if it is not in factored form, then of course you have to do factoring of the given polynomial and transform it into factored form. So let's have the first factor, which is x plus 2. X plus 2. So since that is 0, y is equals to 0, so we will use the zero product property, which means that we would set each factor equal to 0. Okay, so since we have already set, after is we are going to get for the value of x. So make sure that x will remain on the other side of the equation or the equal sign. So we are going to transfer or transpose plus 2 to the other side. Okay, so this is just a shortcut of the addition property of mathematics, the transposition. Okay, so when we transpose from positive, this becomes negative as it is written on the other side of the equal sign. So now we have the first value of the root, and that is -2. So we would write it here, -2. Next factor is x plus 1. Okay, so x plus 1. So x plus 1 is equals to 0. So again, zero product property, where we are going to set each factor equal to 0. So since we are going to find the value of x, so x, we should leave x on the other side alone, and its companion must move to the other side, and we would do transposition as a shortcut. So plus 1, so from positive it now becomes negative here. So our next value for the root is -1. Okay, next is we have x minus 1 is equals to 0. So since this is negative, as we transpose it to the other side, it now becomes +1. Again, you only change the sign of the number if it passes the equal sign, but if not, just retain the sign. Okay, so now our next value is, or next root is +1, and the last factor, which is x minus 2 here, x minus 2, so equals to 0. So again, from negative, this now becomes to positive, so x is equals to +2. So here, that is +2. Now let's go to multiplicity. And the meaning is how many times a particular number, no, is a root. So how many times does negative 2 is a root, negative 1 is a root, and 1 and 2 is a root of the given polynomial. Okay, so a while ago I have mentioned that there are exponents, right, in some of the factors. So for example, that x plus 2 here, so it has an exponent of 2, which means that x plus 2 is repeated 2 times, no? So if we would do this one, we would get how many x is equals to negative 2. There will be 2, because this one we will have the x plus 2, and then the other one is this one, is equals to 2. So there will be 2 negative 2's in this polynomial function. So multiplicity here is equals to 2. It is just equivalent to its exponent, okay? And for x plus 1, which is negative 1, how many negative 1? So the exponent is 3. So there are 3. Next is x minus 1. How many x minus 1? There are 4. So this will be 4. So for x minus 2, we only have 1 as its exponent. So that's 1, okay? Now, let's tell whether the multiplicity is odd or even. So when we say odd, it is not divisible by 2. Or when you pair the number, it has a remainder of 1. So 2 is an even, no? Even number. Next is 3, that's odd because it is not divisible by 2. 4 is even, and 1 is odd. Okay, now, let us look at the behavior of the graph relative to x-axis at this root. So for negative 2, what can you say? Does it cross or tangent to x-axis? So when we say cross, so if this is the x-axis, when you say cross, it cross like that. But when you say tangent, it just touches, no? Tangent means touches only to x-axis. It does not cross, no? It just touch. It just bounds to the x-axis, okay? So for this one, for this root here, negative 2, what do you think? Does it crosses or bounces or just touches in x-axis? It just touches, no? So it is tangent to x-axis. Okay, how about negative 1 here? What can you say about the graph? It crosses to the, from upper side of x-axis, it crosses to the lower side. So that's obviously cross, it crosses. Next is positive 1. Look at it. Does it cross here? No, it is only tangent. And 2, it crosses to the x-axis, no? If you have noticed, if the multiplicity is greater than 1, it has like a flat something, no? It has like a flat, no? It touches or it crosses, as it crosses or as it touches the x-axis. But if the multiplicity is 1, as you can see, it just passes through directly the axis, no? And another thing is, what have you noticed is when does the graph crosses or tangent to x-axis? So it is tangent to x-axis if the multiplicity is even, no? And if it is odd, it crosses, right? So odd, it crosses. And if it is even, the multiplicity, it just touches the x-axis. Okay, so do you have any question? Okay, now let's go to try this to test whether we have really understood. So I have here a given, no? Y is equals to x plus 3 times the quantity of x plus 1 to the power of 4 and the quantity of x minus 2 to the power of 3. So how many factors are there? 1, 2, 3. So there are 3 factors, and as you can see, there are exponents, no? So again, the exponents tell us the multiplicity of the roots of the given polynomial function, okay? So first, let's get the roots. So let's get one factor first, that is x plus 3, then equate it with 0. And let's move plus 3 to the other side so that x will remain alone on the other side. So that's equals to, as it passes through the equal sign, it becomes negative 3, okay? So what is the multiplicity? The multiplicity is just 1, so that is odd. And if it is odd, it crosses the x-axis. Next, our factor, second factor, that is x plus 1 is equals to 0. So let's move it to the other side. So that's x is equals to negative 1. No, the sign changes. What is the multiplicity? So there are 4, negative 1 as the root. So that is even. So that is tangent. Okay, next, the last factor, which is x minus 2 is equals to 0. So that's x is equals to, let's move it here. It will change because it passes through the equal sign. So that's from negative it comes positive. Do not forget that, okay? So the multiplicity is 3. And that is add. So when it's add, it crosses. So now we know the roots. So let's plot them. That's negative 3. So here. Next is negative 1 here. And 2, positive 2 here. Okay. And then we know that the graph will cross or tangent to x-axis. But when are we going to know that it begins falling and then ends with rising? The left hand is falling or the right hand is rising. So we have to determine the degree first. Okay? So what do you think is the degree here of the given polynomial function? So to know the degree is to count how many x are there. So here, there will be 1x because it doesn't have an exponent. Here, it's also 1, but look at outside, there is 4. So it means there will be 4 x's. Here, there will be x here, and there's exponent outside, so 3. So that's 3 x's. So a total of, because when we multiply, we add exponents, right? So 1 plus 4, that's 5, plus 3, that's 8. So our degree is 8, and that is even, okay? And if you remember that if the degree is even, the left and the right hand points at the same direction, right? So which direction? So that's what we are going to determine next. Is it the upward direction or the downward, or the falling or the rising? Okay, so we are going to determine the leading coefficient, the sign of the leading coefficient. If it is negative, it goes down. If it is positive, it goes up. Okay, so here, what is the leading coefficient? That's positive 1. Here, that's positive 1. Then there's 4. Then that's to the power of 4. Here, it's positive 1 to the power of 3. Then let us multiply. Let us first. 1 to the power of 4, that's positive 1. 1 to the power of 3, 1 times 1 times 1, that's positive 1. So positive 1 times positive 1 times positive 1 is equals to positive 1. So our leading coefficient is equals to 1, positive 1. So when it say positive, it means upward. Okay, so since it is, the degree is even, so the same direction, so both are upward. Okay, so we would start it here. So from 3, it will start upward, right? So then, since 3 is an odd, and it crosses, so it crosses down. No, if you try to substitute the values of the value of negative 2 to the polynomial function, then we will get a number, and that is very low there. Okay, so now let's go negative 1. So that's even, only tangent and 4. So that should be very flat, the eye. Okay, let's erase this a bit. Okay, so there, it just touches. And then next is negative 2. That's odd, so it crosses. No? So, but before that, there are points in between. So, of course, it goes down. Then it goes up. Since it crosses, though, that's it. So this is how our graph looks like. So if you want to know what is the point here and the point here, all you need to do is just substitute the values in between. So you can substitute the value of 2 and 0 to the equation, no? For example, so if x is equals to negative 2, what is the value of y? So y is equals to negative 2 plus 3 times negative 2 plus 1 to the power of 4 times negative 2 minus 2 to the power of 3. Then just simplify. So negative 2 plus 3, that's positive 1, times negative 2 plus 1, that's negative 1 to the power of 4. Then negative 2, so that's negative 4 to the power of 3. So Oh, let's copy 1. Then negative 1 to the power of 4, that's negative 1 times negative 1, it's positive. Then negative 1, that's negative, then times negative 1, that's positive, so that's positive 1. And negative 4 to the power of 3, since it is an odd exponent, so it will result to a negative number, kay negative man iyahang base. So negative 4 times negative 4, that's positive 16 times negative 4, so that will be negative 64. So our answer is, y is negative 64. So here, the point here is negative to negative 64. So that's how you have a point here. And in here, you can substitute the values of 0 or the values of 1 so that you would know where to turn. No? Okay, so this now how our graph looks like. Ta-da! No. So like that. Okay, it's like that. Okay, but in this point, there is multiplicity and also here. So since there is multiplicity here, so it should be like that. Okay, so that's it. Hope you learned something. Bye bye. Love lots more.